Can you guys please go to your calculators and in y1 type in 2 to the x? Please. In y1 put in 2 to the power of x. And then press graph. You might want to go zoom 6 because you might have some crazy window from the regressions we did yesterday. You go zoom 6, it sets it back to the standard window. Okay, then we're going to go, so your graph looks like a little growing graph. It like starts slow and then shoots up, correct? It starts off slowly, and then shoots up. Remember with like a line you're going up by the same amount every single time, a straight line. You're just going up by that same slope, right, the whole way. This one you start off with like a slow amount and then you start doubling. When you double stuff, you grow really, really fast. This one's a doubling graph because it's 2 to the x. So for example, if I had 1 bacteria, then I would have 2, then I would have 4, then I would have 8, then I would have 16, 32, 64, 128, 256, 512. It grows really, really fast, right? So that's the graph that we have on your calculator. Can you go second graph? We're going to pull the values off. So this is going to be 2 to the negative 3. What is it? 0 decimal 125? Yeah. Because it's 1/8. Okay, then what's at negative 2? 0.25. Pardonnez-moi. This is 0.25. Then 1. Then 2 to the 1 is 2. Then 2 to the 2 is 4. Then 2 to the 3 is 8. Then 2 to the 4 is 16. Because what we're doing is this is our x, and then to get our y, we're just doing 2 to that x value. Correct? Do we agree? Okay, we're going to plot these. So we have negative 3 and 0.125, so it's just so above. And then we have negative 2 and 0.25. And then we have negative 1 and 0.5. And then 0 and 1, 1 and 2, 2 and 4, 4 and 8, or 3 and 8, sorry. And then it goes off of this. So what's happening is I can start off with something, but I have to start off with something, correct, for my y value? So it's never, ever, ever, ever going to reach 0, correct? It'll get close, close, close. And like, for example, if you have like radioactive material in your body to be able to do like a test, like in the hospital, they'll sometimes give you a little bit of radioactive material, and then you run this test, and then the radioactive material dissipates. It has half-lives, right? So you half, and 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 it never truly goes away, but it's so substantially small that it's not there anymore, right? Same thing happening here. This is going to run getting closer and closer and closer to the x-axis, but it's never going to touch it. So it's running along the x-axis all the way to the end. That is actually pretty good. But it doesn't touch the x-axis. And then this is growing. It's getting bigger and bigger, faster. I can go a little past this with an arrow. I can't go shooting like crazily off because if my last point, I can only go a little past it. And then after that's not accurate anymore, right? You're just doing whatever you want. All right. So another thing to note is on this x-axis, I actually have a dashed line. You have a dashed line on the x-axis. I always say that this dashed line is like an electric fence. So you can get closer and closer and close to it, but you can't touch it. Correct? That's what that little dashed line is. It's like an electric fence. So this is a cow, and the cow is walking along. You can walk along the electric fence, but you can't pass through it. Correct? We hope not. Feel that. So this little red line here is called a horizontal asymptote. Horizontal asymptote. Now, why it's an asymptote? It's the dashed line you can't touch. It's horizontal because it's horizontal. I know, crazy, hey? Now, it's on the x-axis. Does anyone know the equation of the x-axis? It's 0, yeah, but it's an equation. What equals 0? Y equals 0. So our horizontal asymptote is going to be at y equals 0. You want to know the greatest thing about 30-2? It's always y equals 0. We don't have any transformations on our exponential graphs. 30-1, we can move them up, down, left, right, stretch them, reflect them, all the things. So our asymptote can move. For you guys, it's not. It's always going to be on the x-axis because we're looking at a basic function. So the one we're looking at currently is y equals 2dx, and the form that we have our exponential function in is ab to dx, which we talked about yesterday when we did exponential regressions, correct? So if I wanted to write this in ab to dx, I would have to write it as y equals 1, 2 to the x. My a would be 1, correct? My b would be 2. So this is where b, this example is where b is greater than 1. So it's 2 or 3 or 5 or 7 or 9. The graph is going to get bigger and bigger and bigger and bigger, faster, 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 the larger that base value is, right? So at this time it's doubling. If I put a 3 in here, it's tripling, so it's going to grow faster. If I put a 4 in there, it's quadrupling, right? It's going to get faster and faster and faster. All right. Now can we go to our y equals and can we clear it out and can we put 1/2 x in? Please put it in brackets. And I want you to sketch that graph using this table. So for this one, we're going to get 8, 4, 2, 1, 0.5, 0.25, 0.125. Really, really small. Okay. So we have negative 3 and 8. Negative 4. Negative 1, 2. 0, 1. 1, 5. Here. Here. Super here. Okay. So we run along the whole x-axis, not touching the asymptote. Poof. Right? We should label them. This one is y equals 1/2 x, power of x. And this one is y equals 2dx. So that one reflects, if you actually look at the y-axis, they reflect it on it, correct? One is halving, the other one is doubling, which makes sense. One is decreasing at the same rate as the other one is increasing. This one's b value is between 0 and 1. This one's b value was greater than 1. Those are the only b values we can have. We can have b values between 0 and 1, and we can have b values greater than 1. Our b values can't be negative, and our b values can't equal 1, or it's actually a linear line. It's a constant. That's what it would end up being. Okay? So, let's look at these. An asymptote is a line whose distance from a given curve gets closer and closer to 0. An asymptote is an equation where the graph gets closer and closer to, but does not touch. So let's talk about the asymptotes first. What was the equation of the asymptotes for both of those graphs? Y equals what? 0. And these are horizontal asymptotes. Okay, then we're going to look back at both of the graphs. I'll just bring it back. You don't have to. What's the domain of both of these graphs? One goes like this forever and ever. One goes like this forever and ever. X and down to the reals. There's no x's that don't exist, right? Like they're going out for life, going out for life. So my domain is going to be x such that x is an element of the reals. Same for this one. Remember the squiggly brackets, the curly brackets mean the set of x values such that x is an element of the reals, right? Do you get to like write your domain however your heart feels? Like, you know, today I feel like I should really just put another line here. No. You don't get to like just like, oh, I want a double R. You just, no. Like you have to do what it is. And your tests, sometimes it looks like you guys just are like, you know, just letting it flow. I'm just going to see how it goes. And add some things. Extra inequality signs. We're fine. All right. The range. Where does this graph start? Dora. Where does this graph start? The y's. I know someone knows this. Y is what? Can't equal 0 because that's what the asymptote is, but it starts just above it. Y is greater than 0. Yeah, because the whole graph above it, right? Can't equal 0. So do you see where the asymptote exists? The graph can't be, correct? So exponential graphs, range, never have an equality sign because the asymptote is on 0, and you can't go there. It's an electric fence, right? So we have y such that y is greater than 0. Y is now in the reals. It can't be equal to because there's an asymptote there. Remember I tell you all the time that I need you guys to understand why you're doing something, not memorize it. This needs to be a comma here as well. Do you see there's a comma there? Needs to be a comma. X-intercepts of the graphs. There's an asymptote on the x-intercept. Can we ever touch the x-axis? No. So are there any x-intercepts? No. Y-intercept of the graph. Oops. Come on. Where's across the y-axis at? Yeah. So we have to write a coordinate. What is our coordinate? 0 and 1. Then here it says, complete the following statements using the words increasing or decreasing. F of x, 2 to the x, is an example of an what? Increasing, because remember, as the b value is greater than 1, the graph grows. It's a growth function, right? So it's an increasing function. And then here, every single time we're doing anything, it's halving. If it's halving, what's the function doing? Decreasing, right? It's becoming half of the next thing. Well, it's going to go downwards, right? It's a decreasing function. The at and the and kind of gave that away. You understand English. So, little star, star, star. When b is greater than 1, the exponential function is increasing. When b is between 0 and 1, it's decreasing. I want you to tell me if these are increasing, decreasing, or increasing. Tell me you can just go I and D for here because it's your notes. Go. This one has a b of 3. What's it doing? Increasing. Yeah. This one has a b of a third. What's it doing? Decreasing. This one has a b of 10. Increasing. This one has a b of between 0 and 1, so it's 0.2. What's it doing? Decreasing. Okay. What happens if I change my a values? So, let's go through this one. What's the value? Remember the form is y equals ab to the x. This one doesn't have an a value, so what is its a value? 1. Because some people tell me it's 0. If it was 0, 0 times 3 to the x would be 0, right? So that wouldn't make sense. So my a value for this one is 1. What's my a value for this one? 2. What's my a value for this one? What's my a value for this one? 0. Okay, then we're going to talk about b values. What's the b values for every one of these? 3. They're all tripling. They're all exponential growth graphs. They're all increasing. They're all tripling. The only thing that's changing is the a value. Now, if we want to find a y-intercept, we have to plug in x equals 0, correct? So let's look at this first one. Y equals 3 to the 0. What is anything to the power of 0? 1. So that's why this one is 0, 1. Let's look at the next one. We have y equals 2 times 3 to the 0. What is 3 to the 0? 1. It's going to be 1 every time, right? What's 2 times 1? 2. So now this one's 0, 2. What do you suspect this one's going to be? 5. 0, 5. Remember, if I'm writing notes and you're not, that's a problem. I printed them off. You could very well fill them in. Okay. What's the y-intercept of this one? 0.5. Okay, we're going to talk about increasing or decreasing. Does the A value affect if it increases or decreases? No, your A value is actually your y-intercept. Did you notice that? Every single time your A value is your y-intercept? The only thing that affects increasing or decreasing is our B value. What's the B value of all of these? Positive 3. So what is it doing? Every single one of them. They're all increasing. Okay, what's the domain? So you're running arrows first.
Yes.
What's the domain of every single one of these? It's going to be a growing one. What's the domain of it? X now the reals. And then I'm going to be lazy and do this. Because it's showing the fact that they're all that, no matter what. What's the range of all of these? Y is greater than 0. And then here, without the aid of a graphing calculator, explain why none of these graphs could represent this function. Well, let's look at the B value first. The B value is what? 4. So this graph is doing what? Increasing. So that kicks this one out. Because it's decreasing. Then let's talk about this one. This is my A value. My A is 5. What does my A give me? Your y-intercept. Y-intercept of 0, 4. So that's gone. Wait, this one is a y-intercept of 0, 5, and it's increasing. But it says here, explain why none of them represent it. Why is that one out? Below the x-axis. My asymptote needs to be here. That is not an asymptote, that's a straight drawn line. So, yeah, right?